This is our pre-calculus pre-AP fall 2018 ACP sample problems. We'll have 22 problems here representing the 28 problems will be on the actual test. Similar in coverage of content and degree of difficulty, the format. Problem on the graph of f of x equals 1/2 the power of x is transformed using given steps in the order shown, reflect across the x-axis. I'm going to put these steps here just to show what they're going to look like analytically. So you have f of x. If our first step is going to be to reflect this across the x-axis, that's going to be a negative sign out front times 1/2 to the power of x. Next, vertically stretched by a factor of 3. Well, we're going to multiply by 3. So our vertical stretch is going to be this one, f of x equals -3 times 1/2 to the power of x. And then we're going to have translate 1 unit to the right. Well, that's going to be done with that x variable. So f of x equals -3. We have 1/2 to the power of, and here's where we going to, this x here, we're going to go 1 unit to the right. X plus moves to the left and x minus to the right. So we're going to have x minus 1 right up here. And then translate 2 units down. We're going to just, I'm going to just write over the right here, -2. So this is what the thing is going to look like right here. So, well, -3 is going to turn exponential function upside down. So I don't know, just kind of looking here, I'm thinking probably D, but let's go ahead and put this in the calculator just to be sure. We go to our graphing calculator, add graph. We put in -3, and then we're going to have, instead of 1/2, I'm going to put 0.5 to the power of, we had x, it was x minus 1, wasn't it? And then we have, we're going to come to the right here, and we're going to say down 2. Was that it? Let's make sure I get it right here. Yeah, I think that's right. X minus 1 should be it. Let's see what it looks like. So that's this one right here. And it's different than what I thought it was going to be. Yeah, it's going to be this one here, A. It looks like our y-intercept is 8 right here. Yeah, or -8. Yeah. So the correct answer is going to be B. Or excuse me. Is it A? Yeah, A. Y-intercept. Yeah, it'd be A. So A is our correct answer for this one. Okay, let's see here. Next, 2. Which graph represents f of x equals, and we have this piecewise function thing here. We have -x minus 2 if x is less than or equal to -2. And so we see this, and we say x is less than or equal to -2. So we're going to be looking at the end of this at a closed circle, won't we? And so I think that's probably going to eliminate answer choice A, if I'm not mistaken. I think all the others are still in the running. Okay, next, -x squared minus 4 if x is greater than or equal to -2, but less than 3. And so we're going to see at the right, at the left, we're going to have a closed circle, which we already knew based on that. And at the right, we're going to have, it looks like an open circle, possibly. And so we go here, and we're seeing it could be this one right here, this B, and then -6 if x is greater than or equal to 3. Well, we look for that -6, and if x is greater than or equal to 3, so that's greater than or equal to is going to eliminate this d. And I think we should have a fill-in circle there. I think C is eliminated too. I think B is our correct answer for this. So it just takes careful analysis of your open circles, closed circles, where your numbers are. Yeah, another thing wrong with A and C is that you have y equals -5 instead of -6 like it should be in answer choices B and D. Next, 3. Blake is purchasing a new car for $32,000. The value of the car increases at a rate of 9% per year. Approximately how many years will it take? Well, this one here, we had the basic exponential function, which is going to be f of t, and I had t for a number of years, is equal to our starting amount, which we've called in this class sometimes a sub 0, times 1 plus r to the power of t. And here we're decreasing at 9% per year, so r is going to be equal to -0.09, because that's going to be what we need. So we're going to have a sub 0 is going to be 32,000, which is our starting amount for the car, and then we're going to have 1 minus 0.09. And I think 1 minus 0.09 is going to be equal to 0.91. Okay, so and then we have to the power of years, t. So f of t. So how many years will it take for the car? So we have 15,000 is what we're trying to get to. So 0.91 to the power of t. So really we're talking about something we should be able to do a numerical solve on this. And I'm going to go to the calculator and go to that, Control I. I'm going to put, we want 15,000. I'm going to put menu 3-1, 15,000, which is our final value of the car, equals 32,000 times 0.91 to the power of t. That is time in years. And I'm going over to the right here, put a comma t, and I hope this will give us without a error message. So I get about 8.034, right? 8.034 years. So years, yeah, so C is going to be our best answer for this. And then you could have entered this and played around with otherwise too. Gone to table view, we've got close to 8 on this. So there are different ways to do these problems. You could have also just started solving, and you would have had 30. You would have had, like, if you divide by 32,000, you have got 15 over 32 equals 0.91 to the power of t, and so you're going to get t 0.91 to the power of t. So what you have, you'd have log base 0.91 of 15 30-seconds is equal to t, and just put this in the calculator. I guess I'll do it for fun here. So we're going to put control log base 0.91 of 15 over 32 So we get, yeah, same answer. Okay, next, 4. The first 3 terms of sequence are shown, and you get a pattern here where these things are adding 4. This is what kind of sequence we're talking about. This is called an arithmetic sequence because we're going up by the same amount every time. So D is equal to 4, and it's going to be plus 4. And our first term, a sub 1, is going to be equal to negative 83. And so we can just take these and make another 48 digits and add them all up to get the sum, and do that by hand. That could work out. But what we want to do is use our ACP formula chart, where you have the sum of series is equal to the number of terms over 2 times quantity a sub 1 plus a sub n. And already we have n is 51, we have a sub 1 is 83. We need to have a sub 51. So the formula for that is a sub n equals a sub 1 plus our common difference times quantity n plus, no, I said n plus 1, n minus 1. And the formulas are here in our ACP formula chart. We can see them right here, right? This is going to be the nth term, so we can get the 51st term using this. And then we can use that summary formula here. So we have the formulas right there. And we've been showing them in this class. So we want a sub 51. That's going to be a sub 1, which is going to be negative 83, plus d, and d is 4. And then we have 51 minus 1. So we're going to have negative 83 plus 4 times 50 is going to be 200. So negative 83 plus 200 should be 117, I think. And I'm going to do this in the calculator just to be sure. So I'm going to say negative 83 plus 4 times 51 minus 1. So that should give that, yeah, 117. That's right. So now we have the a sub 51. So our summation is going to be our total number of rows, which is 51, over 2 times our first term, which is negative 83, plus 117. So that's going to give us our answer. So we go to our calculator, we say, here we're going to have 51 over 2 times negative 83 plus 117, and there we have it, 867. So 867 is our answer. So we need to put 867 just in consecutive correct places. They can be anywhere here. I could have put all these 3 digits on the right or to the left. I don't have to put a plus sign in that. The default for this is a plus if there's nothing else. So put 867. They're going to be probably on your test 3 or 4 of these free response type bubble in problems. Get them right. They shouldn't be too hard. Don't be lazy about them. 5. Polly was given a rational function. What discontinuities did Polly discover upon her investigation of this function? So you have different ways you can do this. One thing you can do is kind of graph by process of elimination. I'm going to graph first just to get that going. So we have quantity x plus 3 over x squared plus x minus 6 And we come to the right here, and we're going to be adding 2. So kind of double check. Yeah, that's what it looks like. Okay, so we're going to look like this. And so it looks like we have an infinite discontinuity where x equals 2, right? Or a vertical asymptote. And so we have a vertical asymptote where x equals 2. Well, that looks like answer choice A. Well, I'm thinking A looks like the only possible right answer. A removable discontinuity x equals -3. Well, let's go take a look at that. I don't see anything at x equals -3, but a removable discontinuity is not going to show up. Let's go ahead and put Control T, look at the table view, and we see we have undefined at 2, x equals 2. We already knew that through the vertical asymptote. And there at -3, we also have a discontinuity, but not visible on the graph, meaning it's a removable discontinuity. And so that's going to be that. That's going to be A, no doubt. And then we can factor and simplify this too. We take x plus 3, and in the numerator, we can factor this x plus 3 into quantity x plus 3 times quantity x minus 2. And then we have plus 2 at the end. And you can see that x plus 3 over x plus 3 cancel. So that explains our removable discontinuity x equals -3. And then it also explains, so we don't have an offset, our vertical asymptote at our infinite discontinuity at x equals 2. So A is our definitely correct answer. 6, what is the 6th term in the expansion of x minus 2y to the 10th power? And we've worked these, I've kind of tried to prep you over the, and so we can use the Pascal's triangle, this 1, 1, 1, that's our first row, 1, 2, 1, that's 2, and 1, 3, 3, 1, that's our third row, and we could continue like this. Or, but one thing that I have done is, and that can be done quite easily, almost in the time I've taken, you can be down to the 5th or 6th row and on your way to 10th row. One thing that I've shown is how to do this in the calculator. And what is the 6th term? Well, the term numbers are 0, 1, 2, 3, 4, 5. So when we go use NCR, we're going to have to use the 5. So if we go NCR and 10, choose, I think the way they look at like this, NCR, and I think it looks like this, 10, choose 5 is the way it looks like. And in the calculator, this is what it's going to look like. I'm going to go Control I and go to Add Calculator, Menu, Probability, and 3 combinations. So NCR 10, which is the number of expansion, comma, and press Control, close parentheses, we'll get a bracket. We want the 6th term, so we put in 5. So that's going to give us our coefficient on this thing, which is 252. So that'd be, if we expanded it with Pascal's triangle, that would be quite something. So 252 would be our coefficient. And in our 6th term, our first term is going to be x to the 10th. Our second term is going to be x to the 9th. Our third term is going to be x to the 8th. Our fourth term is going to be x to the 7th, and then x to the 6th, and then x to the 5th. So that's what we're going to be looking at. X to the 5th will be the 6th term. Yeah, that's going to eliminate A and D as incorrect answers. So we're going to get 252. We're going to have x to the 5th, and then we're going to have this negative 2y also to the 5th, because they have to add up to 2. So we're going to get 252 times negative 2 to the 5th power x to the 5th y to the 5th. And I think it's going to have to be this b. Why is that? Because you're going to have a negative 2 to the 5th power. That's going to be a negative number. So let's put this in here. 252 times, we're going to put in negative 2 to the power of 5. For that, we get negative 8,064. So x to the 5th, y to the 5th. Yeah, that's right. Answer choice B. Next, 7. Which graph represents the function f(x) equals x to the 4th plus 5x minus 2 over 3x squared minus 12 plus 2? So we're going to go to our graphing calculator again and put this in, control. There we go. So we're going to put in x to the 4th plus 5x minus 2. And that's going to be over 3x squared minus 12. And then we come out here and we're going to add 2 to this. So plus 2. And so that's what we're looking like here. And we don't see the whole thing. I think we might have to change our window view to see everything we have in our problem. Yeah, they're going to 10 and minus 10. So let's go ahead and change the window view just to be sure here. So go to menu, window, and window settings, and we're going to go down to y equals negative 10. Tab down here to y equals 10. And this should get it for us. We should be able to see everything here. Yeah, we see the little nub, what it looks like. So it's definitely not B. Okay, others look kind of similar. I think we're coming down to negative 10. I'm thinking it could be, I'm feeling better about this A. Let's take another look at it here. Oops. A. Yeah, it comes down to 8. Yeah, I'm thinking A looks like your best shot on this one. So again, it's just going to be matching and kind of looking at it. So we're going to choose answer choice A. Next, 8. Which list represents all possible rational zeros? Well, the possible rational zeros we've talked about a few times in this class. We're going to have plus or minus factors of last. Well, we're going to have the factors of negative 7 or 7 are going to be 1 and 7 over the factors of the coefficient of the first, which are going to be 1 and 3. And so we're going to have plus or minus 1 over 1, which is 1. And then we're going to have plus or minus 1 over 3, which is 1/3. And then we're going to have plus or minus 7 over 1, which is going to be plus or minus 7. And finally, we're going to have plus or minus 7 over 3, which could be plus or minus 7/3. So that should be pretty simple. Where do we have all these? I'm thinking this is answer choice D. Okay, let's go on to number 9. The annual growth rate for an investment is found using the function. Here you have this logarithmic formula. Since we're trying to find the present value, so P is the present value. So we're trying to find this P, and we have all these other pieces. And that's one thing on the pre-AP test. You have a lot of these equations that you need to solve. So R is the annual growth rate. So R is equal to 3.7%. But that's going to be in a percentage form. In a decimal form, which we need to use in equations, we're going to have 0.037. So let's go ahead and use this. We have 0.037 is equal to 1 over t, and t is defined to be 5 years ago, right? So 5, so we're talking about annual growth rate. ln, and ln is our natural logarithm of p, and we don't know what p is, over p sub 0. We know what p sub 0 is. That's going to be 5,000. So 5,000. And this is a perfect situation for n-solve because you have the unknown you're trying to solve for kind of mixed in the middle. Yeah, we could go ahead and do a logarithmic like we've done before, but let's just go ahead and put this in our n-solve. Control I, add calculator. Okay, menu 3.1. So we're going to have for this one 0.037 is equal to 1 over 5. I'll just put it in like we had it here. 1 over 5 times ln, control e to the x. We're going to make a fraction here. I'm going to put p over p sub 0, which is 5,000. And so we have our equation here, and we're going to come outside here and press comma p. And I hope we don't get an error message on this, please. Okay, $6,016.09. So p equals $6,016.09. And do we have that? Yeah, we do. Answer choice C. Another thing is that you kind of, for things that make sense, if you went ahead and took this $5,000 and you wouldn't get exactly the same, you have 1 plus 0.037 to the power of 5. Is it 5 years? Yeah, 5 years. You should get close to that same amount. So if we take 5,000 times 1.037 to the power of 5, we're not going to get exactly the same, but we're going to get close. Okay, so that's close. But really, and the only one anywhere close to 5,999 is this C, but that's a continuous basis. Okay, 10, which equation represents a slant asymptote? We didn't really talk about slant asymptotes, but I'm going to go ahead and enter this equation, and we're going to see which one matches. And so we're going to kind of see what a slant asymptote is if you haven't looked at one yet. We haven't had time this year to go over everything to the extent that I would have liked to. And so that's just kind of the limitations of where we are. So we have 2x cubed here in the numerator. And we have minus 5x squared minus 8x plus 1. And in the denominator we have x squared minus x plus 5. And then we graph this, and we're looking for the equation of a slant asymptote. And a slant asymptote is going to go right through here, kind of where I'm drawing the arrow right now. So really, just looking at the answer choices, the only ones that to me look like they could be conceivably right answers are answer choices A and B. So we have 2x minus 7 and 2x minus 3. So I'm going to put tab. I'll put 2x minus 7. Enter that. There's 2x minus 7. I'm going to go and enter 2x minus 3. And if you see this 2x minus 3, this yellow, this orange one, it kind of goes right between the two. The green one is not like evenly split between the two. So the best answer is going to be this answer choice B, this 2x minus 3. And so you kind of look for the symmetry on those types of problems. I don't know exactly what kind of problem you're going to get. In this case, B will be our correct answer. 11, Newton's law of cooling. This is kind of like two problems ago where you have the formula that you're going to put things in for and get this. So you have these pieces, just like a scavenger hunt of numbers. You have this this t sub t. That's our final amount. We have a constant k. We want to know. Okay, we don't know t sub 0. So t sub 0, that's going to be our, I'm going to put a little question mark down here. So that t sub 0 is what we're going to be solving for. But we have everything else. We have the time, 5 minutes. We have the medium temperature, 20 degrees Celsius. So let's just go ahead and put things in here. We're going to have 48 is equal to t sub m, and t sub m is our medium. That's going to be 20 plus, we have parentheses, t sub 0, which I'm just going to put as t, minus our temperature of our medium, which is again 20. And you can see 20 in two places, can't you? T sub m's in two places. Then e to the power of negative, and k is going to be 0.35, and t is going to be, it was 5 minutes. So if we put this in to an n-solve situation like the others, we should be able to get this, I would hope. So go here, Control I, add calculator, menu 3-1, too few arguments. What am I doing? Yeah, I didn't even, okay. We have 48 equals 20 plus parentheses, we want to get t sub 0, t, plus our medium temperature, which is 20, and then we're going to come out here, we're going to say times e, and where do we get e? This e to the x, e to the power of negative 0.35 for a value of k, and then over here times our value of t, which is 5 minutes. And then we come out here and we can put comma t, since t is what we're trying to solve for, and we get this thing here, 141, and I guess that's degrees, so that's t sub 0, right? Okay, t equals 141.1 degrees Celsius. And I do not see anything like that here. 48, 5, let's go look at this. Negative, the initial. What's it? 20 plus t, 48, 20, 20, negative 0.35. Let's see what I got here. Negative 0.35 times 5 t. You know something, what I did? I know what I did wrong. That's supposed to be minus 20 there. So yeah, that's what I did wrong. Okay, let's try it again. Menu 3-1, 48 equals 20 plus control t. This time we're going to subtract 20 like I should have done last time. And then we're going to come out here and put times e. Oops, I don't want control. Okay, times e to the power of negative 0.35 times 5, and then come over here and put comma t for t sub 0. We get 181.1. So let's try this. We'll say 181.1. That looks better, doesn't it? Degrees Celsius. Yeah, so C is our correct answer. And if you think about it a little bit, it probably makes sense. Okay, 12. A polynomial function of degree 4 is graphed as shown. And this has to do with our fundamental theorem of calculus, our fundamental theorem of algebra. I said calculus, meant algebra. And that is the number of zeros or roots is equal to the degree of the function. And so your number of roots is going to be 4. And so anything without 4 as an answer is an incorrect answer. So B and C are automatically eliminated. And then extrema, local extrema. Well, here's a relative minimum. That's a local extrema. A relative maximum. That's a local extrema. A local minima. Your extrema is going to be at most 1 less than number of roots. And so our correct answer for this one is answer choice A. Another thing you could have done, I guess, you could put points here and do a quartic regression and get an example one. Okay. 13. A ball is dropped from a height of 6 feet. Return bounce is 0.82% of its, or 82% of its previous height. How far is the ball traveling? Hits the ground for the 6th time. So we've done this a little bit in class. I prepared for this last year. It didn't show up in last year's test. But you never know. This is in the sample problem. So you have the ball that's dropped from 6 feet. Okay, so here's 6 feet. Put 6 feet, right? And then you have the ball bounces up once to 0.82%. Okay, that's our bounce. Come down, hit the second time. 0.82 of that. Come down here. Okay, that's heading for the 3rd time. Okay, 0.82 of that. Okay, coming down, that's for the 4th time. 0.82 of that for the 5th time. 0.82 of that for the, and then coming down for the 6th time. So that's 1, 2, 3, 4, 5, 6. And so you're going to have 6. That's going to be 6 plus 6 times 0.82, and you're going to have to multiply by 2 because you have the up and down. And so I'm going to now combine these and make these 12 because 6 times 2 is going to be the same case for all of these. So that's 1 bounce, 2 bounces. So I'm going to put 12 times 0.82 squared. Okay, that'll get us to 3 touches plus 12 times 0.82 cubed. That gets us to 4 plus 12 times 0.82 to the 5th. No, excuse, I said to the 5th. I meant put to the 4th. 12 times 0.82 to the 4th plus 12 times 0.82 to the 5th. So now you have something you can work out in a calculator, and I'm going to go to the calculator right now and put in 6 plus 12 times 0.82 plus 12 times 0.82 squared plus 12 times 0.82 to the power of 3 plus 12 times 0.82 to the power of 4 plus 12 times 0.82 to the power of 5. And so it's going to be this 40.3996. And insert nearest 1/10 of a foot. So that's going to be approximately equal to 40.4 feet, right? So I'm going to put over here 40.4. So 40.4. So I'm going to put in 4 0.4. There we go. Okay, very good. Let's go on to number 14. We have the number of downloads of new song grows continuous exponential rate. Well, the continuous exponential rate has to do with the formula. Let me kind of show you the ACP formula chart. If you go to, see, we have this. Your continuous exponential growth or decay is going to have this E involved in continuous compound interest. They will have an E to that. And so really, based on that alone, your A and B will not be likely correct answers. So you got to choose between C and D. And we can try these different ones and see what we get. If we put it as a function, I'm just going to go to the calculator and I'm going to try to short circuit the one I think is the right answer just to save time. I think that D is our correct answer, and I'm going to put in 1200 times e to the power of 0.442220x. And then we graph this. We can't see it at all, but then we go to table view, Control T, and we see at 0 we have 1200, and at year 5 we have 9897. Let's see what we have here. Yeah, 9897, pretty close. 9897. Yeah, so that's going to be it. Our answer choice D is our correct one for this. 15. Matthews and friends are going to a concert. They hire a car service for $75. Take them to a restaurant for dinner and then a concert. They divide the cost $60 for the dinner equally. However, so what we have is we have an equation where the friends is equal to X, okay? And Matt plus friends is equal to X plus 1. And so how many friends go to the concert? Well, we know that the car service, $75, is going to be divided by how many pieces? Matthew's dad provided, so the pay for the car, that's the car service. Okay, car service is that, so that's going to be divided by X, plus we have the concert cost, the dinner itself is 60. That's going to be divided by Matthew plus and his friends, so that's going to be X plus 1. And then the average for that, if each friend spends $25, so that's going to be 25 right here. So we can do this, we can enter these numbers in here. One way we can do is solve this by graphing. And to do that, we can set one side equal to 0. If we just subtract 25 from each side, we have 0 is equal to 75 over X plus 60 over X plus 1 minus 25. And just kind of see what that looks like. So let's go to the calculator, see what we got. We go to Control I, add graph, and we're going to say, okay, we'll have 75 over X, and we're going to have plus 60 over X plus 1, and then we're going to have minus 25. And what are we going to look like? Well, we see two answer choices here. 1, 2, 3, 4, 5. So 5 is our correct answer for this. So x is equal to 5. One thing you run into trouble if you go to do this thing with nsolve, you're going to get, and I've done this in the other ones, you'll get this negative 0.6 as your correct answer, and that's a limitation of nsolve. You only get one possible right answer out of that at most. So that's a neat little problem. I don't know if you get one like that. Okay, 16. If f of x equals x squared plus 2x minus 1 and g of x is 3x, what is f of g of x? What we got to do is we have the x close to the g, so we got to throw this 3x function into the x here for here, and also into this x here. And then we just simplify. So f of g of x is equal to, we're going to put 3x squared plus 2 times 3x minus 1. And so we're going to get is 9x squared plus 6x minus 1. Where's that going to be? Looks like that's answer choice D. Next, 17. If f of x equals 8x cubed, which graph represents f negative 1 of x? So we can do our 4-step process. The first step is change that f of x to y. So I'm going to put down y is equal to 8x cubed. And so I'm going to switch x and y. So x equals 8y cubed. And solve for y, we're going to take the cube root of both sides. Well, before that, I don't want to do that next. I'm getting ahead of myself. First thing I want to do before that is, switch x and y. Let me do that. X equals 8y cubed. Okay, we got to divide by 8. There we go. I'm going to get this right eventually. So y cubed equals 8x over 8. And now, taking the cube root, we're going to get y is equal to cube root of x over 8. So whatever that looks like is going to be it. So it's going to be probably answer choice A. Let's go ahead and look at that for sure. Y equals, I'm just going to go here to tab. Y equals cube root, and how do we get that? Well, I'm going to go, there we go, cube root of x over 8. There we go. Yeah, that's going to be our answer choice over here, answer choice A. Next, 18. What is the domain of this function? And basically for this, we can graph this in a calculator. We can eliminate answers possibly too. If we look at this, we have brackets here surrounding -3 in both places, which means probably B and C don't really make sense. So let's go ahead and work this out. If we have x on the top and to factor the bottom, we factor out an x. We're going to have x times quantity x plus 3. So x cannot equal 0, and x plus 3 also cannot equal 0. So x cannot equal 0, nor can it equal -3. So really, our only answer choice that makes sense for us is this. And if we graph the function, we're going to see a vertical asymptote x equals -3, or we're going to see a removable discontinuity or no discontinuity where x equals 0. So that's just something to look out for. I'm going to go ahead and graph this just to show you what it looks like. Control, we have x over Okay. X squared plus 3x. And see, that's at 0, we don't see it. At -3, we do see it. Where we do see it in the calculator is not on the graph view. Let me go back here. Where we don't see it is, okay, we have undefined at 0, right? We do not see that discontinuity, but at -3, we do see that vertical asymptote at x equals -3. Okay, that's 18. 19. The formula to calculate the level of sound intensity in decibels dB is, and so we have the pain threshold for human ears 120 decibels. What is the intensity I? So again, it's one of these things we have a formula to put 120 for our decibels is 10 times log, and we're going to have I, and so that's going to be I over I sub 0, and that's 10 to the negative 12 power watts. So 10 to the negative 12 power watts. And if we solve for I, we should be able to get our correct answer. So we go to our calculator. I'm going to put Control I, go to numerical solve, menu 3-1, and then we're going to put 120 is equal to 10 times log, and here's a control log. I'm going to put 10, and we're here. We're going to put, I'm going to put I for sound intensity divided by 10 to the power of negative 12, and then we're going to come out here and outside the parentheses put comma I, and then we get 1. Okay. Well, how do we write 1 as a power of 10? Well, 10 to the power of 0 is equal to 1. And so if you have, we could work it out and explain what that is, but our correct answer is C, 10 to the power of 0. 20. We have which function is removed by discontinuity at x equals 2, and we can look at these different things here. This one here might be a jump discontinuity. I'm gonna factor these. I think the answer is going to be C or D. So this one here on numerator C, we got x times quantity x plus 2, and down here below we have x plus 2 times x minus 2 factored, and x plus 2 cancel, and x plus 2, so x minus 2, that's going to be a non-removable discontinuity. So I don't think C is our right answer. Let's go look at this one here. X equals 2. Down here in the denominator, we get x times quantity x minus 2, so that looks good. And then on the top here, we're going to get this x squared plus 2x minus 8 is going to be x plus 4 times x minus 2. Well, this x minus 2 over x minus 2 cancel each other, so that's going to be a removable discontinuity at x equals 2. So that's problem 20. Problem 21, what is the sum of arithmetic series? Again, at this time in this class, I haven't gone over this yet. How do you do this in a calculator? If I go to my calculator, it really shows how to do that. We go right next to the 9 key, and we have this icon right here in the middle row over toward the right. So we press that, and we just enter that as k equals 3. So I'm going to put k is equal to 3, and then we're going to come up here, and it's going to be to 10. And then over here on the right, we're going to put 5k minus 12. I'm going to explain what that is in a second. And so we get 164. So equals 164. That's answer choice B. What this is showing is it's saying, okay, k equals 3 through 10. So what you're going to do is enter 3. So we have 5 times 3 minus 12. And then put in k equals 4. Okay, all the way up to 10. And then add all those together. That's what you're going to get. So you're going to get, so you have like 7 numbers you add together. Okay, 22. The graph of the function h of x is shown. Which graph represents the transformation g of x equals h of x minus 5? So we have x minus 5. Remember the song? Merry Pre-Calculus Christmas. X plus moves to the left and x minus to the right. So that's going to be 5 to the right. So 5 to the right. So how do we go 5 to the right? Well, that's going to be not A or D. And then we have minus 6. And we are going to go legitimately go down 6 and not up 6. So this one here, as choice C, is 5 to the right and down 6. Okay, 5 right, down 6. So C is going to be our correct answer. So that's going to be all the sample problems. That's not everything that's going to be on it, but sort of the degree of difficulty and broadly the content that's going to be on that test. So good luck, good studies, and thanks for viewing.